I'm going to go ahead and get started. I'm going to put this on YouTube, so if people join the stream late and want to follow up later on, they can always go back and view this on YouTube in the archives. So this is going to be very informal. Don't have much prepared. I'm going to be kind of going through the whole process of learning and scheming and figuring out what I'm going to do for this game. I'm going to learn the LibGDX game engine and program the game from scratch. So let's go ahead and get started. So what's this game? I have the working title familiar. So a familiar, if you know your fantasy role-playing scenario, is a pet for a mage. And there's going to be an element to the game where there will be a second player who will be able to play this familiar, but I'll talk about that a little bit later on. So first, what are the main elements of this game? First, it's going to be a metroidvania style game. So if you don't know what that is, it's a combination of Metroid and Castlevania. And some of the defining elements of Metroidvania are that it's generally a platformer. It has different areas which are locked off at the beginning of the game, and as you get upgrades, you're allowed to traverse the full map. What else? So I want to do a procedural generation of the maps. I want to allow for some emergent gameplay. And what I mean by emergent gameplay, well, emergent gameplay means things that I haven't necessarily planned for, the players are going to be able to do. I mean, here's one sort of contrived example. So let's say that there's a wall that the player wants to get over. And maybe there are other elements, in the game which would allow you to traverse the wall, like climbing gloves or a double jump. But you don't have any of those things yet. But what the player does have is a bow and arrow. Well, one thing we could do if you set up the systems, a player might learn that they could shoot arrows into the wall and use that as a makeshift ladder in order to jump up and over the wall. So that's what I mean by an emergent gameplay. It's different systems that allow players to sort of create their own paths. Hang on one second, my cat's scratching at the door. So we're also going to have this element of sort of two-player system. And this is inspired by sort of the Binding of Isaac multiplayer, which came in a later version of their game, where you had two players who were they're not equal. So one player sort of plays a primary, plays Isaac or the primary character, and then the second player plays a familiar, a smaller character who takes us like one heart from the primary character. And there are a couple of reasons why I want to do this familiar system. And one is, so you may have two different people in the same household who have different skill levels. So one player is a very skilled gamer, and the other player is younger. So I have young sons who aren't as good at games as I am, or haven't had as long to learn how to play them. And so you can hand the second control to this other player, which might be an easier control, or have less consequences for playing the game not as well. So that's what the familiar is going to be. For the first implementation of the system, I'm thinking that player one, who plays the main character, the platformer, player one will have a controller, like a gamepad. Player two could just use the mouse. So if we're playing this on a PC or a Mac, then one player has the mouse and they control this familiar, who could be, a will-o'-the-wisp or a fairy or an imp, and player one's using the gamepad to control the character, the adventurer, around the level in sort of a typical platformer way. And as we progress, then I would also like to look into, instead of just using the mouse, maybe move to a true multiplayer, and then we could allow the player two to control the familiar using a touchscreen interface, like a tablet or a phone. So we'll call the player one the adventurer for now. So these are sort of the starts of my thoughts for the game, but let's go ahead and get started. I think I want to sort of begin to play around with LibGDX and see what I can do. I'm pretty familiar with Java, but not very familiar with LibGDX or game programming in general, so it should be an adventure. And I hope it's helpful for some people, not too frustrating for people who know more about programming than me. Let's go ahead and get started. So I've already used this LibGDX project generator. You can download it from the LibGDX website, and I've already used it to generate my project, which for now it's just a desktop project. As I proceed along, I may decide to add Android and iOS targets, but for now I'm just keeping it simple and just targeting the desktop. So I'm going to go over here to my IDE, IntelliJ, and this is sort of the starting point. So this is the basic code that comes when you've generated your project. Hit play, it'll pop up, and here we go. We have a window with the Bad Logic Games logo in it. It's resizable. The red background. Let's see what happens if we change one of these numbers here. Yeah, so we have black background. Sort of what I would expect. So this should be RGB, so let's make this one. Should have a green background. Yep. All right, so that's all pretty straightforward. Now I'm going to use a lot of the optional libraries. I don't really believe in reprogramming systems from scratch if there's good libraries out there. So the primary one I'm going to be using is called, where is it? Ashley, and this is a entity system. So this allows you to very efficiently apply sort of common components to your different entities. So you may have a bunch of different sprites on the screen that need to be moved and repositioned and displayed. And you can add components, common components for each of those entities to make those sprites move and be displayed and rendered. So I'm going to use this. I may not need to use it a whole lot to begin with. I think I'll try and get something very basic set up. I may use this. I'll definitely use this later on. I'm not sure if I'm going to use this right off the bat or not. So the other library I'm going to use is Box2D. It's a physics library for 2D graphics. And there's also an optional utils package, which I have installed, which simplifies some things. It creates a Box2D Sprite, which combines the functionality of a Sprite and the Box2D physics library. So I'm going to use that. So here's an example of the Box2D Sprite. So I've used Box2D in the past, so it looks like we need to create a world. This is what we sort of simulate our physics in. And then we're going to step through the physics simulation. And it looks like we can, it's interesting, Box2D Sprite. Okay, so you can there's a batch. This must be for the efficiency of rendering sprites. And then when you draw the Box2D sprite, you pass in the batch, and you pass in the world. That's a sprite batch, okay. So it all seems to be pretty straightforward. Well, I'll tell you what, let's type in some of this code and sort of see what happens here. Give me 1 second to get this on my second screen. All right, let's get started. I already have the sprite batch set up here. I sort of want to make these private. I know they start off as protected as by default, but there's no reason to share them unless you absolutely need to. Share them within the same package, in which case we can call them protected. So let's see here. We need a camera, looks like. Let's just make an orthographic camera. There we go. We need our Box2D world. Seems right. Okay. And let's go to the create here. Also, this they're using this debug renderer. Do we need that? They probably use that to show like frame rates and different kinds of. Let's go ahead and do it. Let's do the example just as I have it. Okay. So let's create that. All right. All right. What do I need next? New world. New world. So I'm not sure. Oh, this is gravity. Okay. So for the gravity, we're going to pass in a vector 2. And there's going to be no gravity on the x-axis, and there's going to be negative 9.81 F gravity on the y-axis. Okay, put that. Okay, so some box 2D objects here. All right, we'll create the ground now. So be a body. Be static. We don't want the ground to be influenced by the gravity and fall. Oop. Is that right? Okay, we'll import that statically, I think. That's fine. So here's the ground. Okay, and here's the this will be the starting position of the ground. Let's take a look. I'm gonna hop straight into the Java docs here. Here we go, Java docs. Box 2D. We're looking for, let's see here. I'll look at the edge shape here. set this as an isolated edge. So v1x, v1y. Okay, so there's two vertices, x, y, x, y. So negative 50, 0, 50, 0. Okay. So that just means that we're creating an edge between those 2 points. So we got negative 50, 0, 50, 0, and that's going to be our ground between those 2 points. All right, so that looks okay. All right, so now we actually, we're going to use this fixture def to create the ground. The shape of it is going to be this ground shape that we've defined. And we're going to set restitution to 0. I think that is how bouncy the ground is, but let's take a look. So that's under fixture def. Restitution, elasticity. Yeah, so I think it's like how much, if you bounced a ball against the ground, how much of the energy would be reflected, how much is absorbed. But we can play around with that and see what changing that does to our simulation here. And friction, that's more straightforward. And now we're going to add this to the world. Okay. And then we don't need the ground shape anymore, so we can dispose of that. I kind of want to run this and see what happens. I don't think we're going to see anything though. We can try. I think I need to add something to render though. Let's go back up to our render function. We need to step through our simulation here, or physics. This is 1/60th of a second, I suppose. Let's take a look, rather than just guessing what we're doing here. All right, so let's look at what the world.step function does. I should say method. I do a lot of JavaScript during the day, so I may get my terms mixed up. Okay, so world, let's take a time step. All right, so we have time step, velocity iterations, and position iterations. Okay, so you can, it's interesting. So you can simulate the velocity, the change to velocity at a different rate than you simulate the change of position. And again, we can play around with that. I'm not 100% sure why you would do that. There's more in here. This might be something which you do for optimization, performance, make things seem smoother. All right, but anyway, let's continue with the example. The other thing is this box 2D sprite. To use the box 2D sprite to draw the batch. Okay, well, I don't think we have anything set up yet. No sprites, so it's probably not going to do anything. Let's just run this, see what happens. We might have something. Oh, we still have the Bad Logic Games logo here. Let's get rid of that. Let's change this to box 2D sprite draw batch world. Comma. No, it's capital D. I'm sort of curious if we can start to see things using the debug renderer. Let's add this to dispose. I don't see it being used in this example. Oh no, here it is. It's in render. It's like this, debug renderer.render. Camera.combined. All right. Let me set up the camera too. See if you see anything now. Oh, yeah, there we go. So that green line there is our ground. So that's great. Oop. So it doesn't like disposing of image because there is no image. Okay. I don't know why it's using tabs at all. Pretty sure I have it set up to use spaces. Let's get rid of this for now. All right. So next, let's add a ball. We can roll a ball on our ground. Okay, so we're going to create a dynamic body now. Yep. All right. And we're going to place it 10 pixels from the bottom left corner up. We'll give it some velocity, angular velocity. So I'm assuming that means that we're going to see let's see, it was a ball somewhere like here. Try that again. And it's going to have some sort of velocity, so it's going to be moving -10. Let's look at that again. Stop guessing. Body def dot angular velocity. So what does -10 units mean? Clearly, it's going to be influenced by gravity as well. There it is, angular velocity. Doesn't really tell me much what that means. The rate of change of angular position of a rotating body. So it just means that okay, I get it now. So rather than moving in a linear fashion, that just means that this ball is going to be rotating. Presumably the gravity is going to take over and it's going to bring it down to the ground, and then the angular velocity is going to rotate it and make it roll. So we'll see if that is the case. Again, if you are a game developer and you're very familiar with LibGDX, I'm sure you're probably facepalming and you're very angry at me, but you have to be a little patient while I figure these things out. All right, so now we have a body. We need to apply a shape. Okay, circle shape. All right. Let's set the radius. 0.5. So we set the shape. Maybe a few more properties to set here. The density. The restitution. Again, I think that's how bouncy this ball is. And friction. So if it was 0 friction, presumably it would just keep rolling forever and never stop. We're going to add this ball to the world again. So world, create body, the body def, create fixture, fixture def, set user data. I'll look this up too. Okay, so this asset is obviously something which I need to create. Yeah, this is an import, which I don't have. Let's get rid of this for a second. Let's just see what happens. Presumably, we should still be able to see this in just using what's it called again? The debug renderer. So let's take a look and see. Oh, there it is. I saw it for a second. It was very large and it bounced. Let's see. Let's take a look what this radius, the units of this radius is. 0.5 f, 0.5 float. Doesn't seem like it would be too large, but this is a circle shape. Okay. There's got to be a better way to navigate these things. Let's see. Set radius. Float radius, okay. Hmm. So, yeah, I mean, I saw it for a second, and then it sort of bounces out of frame and disappears. It's not coming back. This floor seems pretty high. Maybe the issue is that my camera is set sort of centered. I need to move it to put the ground, closer to the bottom of the window there. Let's clean it up here. One thing they're doing is they're using the resize method here, which I don't think is set up yet. We're using the application adapter here, which allows us to ignore methods we don't want to use. Let's see if that helps, though. So we can add this override annotation. They set the viewport width and viewport height. So the camera viewport is 1/25th of the width and height. So there's that camera to combine thing again. Let's take a look what this means. So we have batch.set projection matrix. So Sprite batch. This is probably really boring for everybody, but that's fine. It'll get more interesting a little bit later on when we start getting into the meat of programming the game here. For now, I'm just trying to learn Sprite batch. Sprite batch, set projection matrix. Camera combined, Orthographic. The combined projection and view matrix. Well, that doesn't really help me. Let's see where we're at with this. Looks like I have one other. Oh, okay, that's better. That's a lot better. Yeah, so it's rotating. That's our angular velocity. You can see the gravity. Very cool. Looks like I actually have yeah, I have it running one more time. Just get rid of that. Okay. Box 2D. So the that's interesting where it's being placed. Position y equals 10. I guess. It seemed to change anything, did it? This is warning me that I'm not one device not closed. So my dispose method here. Let's see what you're doing. No, I guess I didn't dispose of ball shape here. I'll get rid of that, I guess. So it still looks like the ground is basically halfway. Exactly halfway the screen. Yeah, that got rid of the error message when I disposed of this. So I guess it complains if you don't properly dispose of all your objects here. No, now I don't see it. Interesting. So we could do, let's see, make the ball, presumably we could make it bouncier, right? Let's see if I set that higher. Yeah, maybe a little bit. Yeah, it seems like it's definitely bouncier there. It'd be great if I could live edit these and just have it change without having to reload. I don't think that's a feature of LibGDX though. I'm going to pause here for a minute, just check on everything, and I'll be back. I'll do another few minutes of scheming here and then call it a night. So just want to type up some of my ideas here, to be a little bit of brainstorming, talking out loud, talking through my ideas, seeing what sticks. So metroidvania style, I think I want to make it have distinct screens. So what that means is, instead of being like a seamless world with levels and having it be all one gigantic level that's all interconnected, I'm going to divide up the world into distinct screens. I'll show you what I'm talking about there. So in a Metroidvania style world, you might have a a large world that you can't see everything at once. So we divide it into separate screens. All right. Do something like this. And each of these separate screens has entrances and exits. So maybe you'll have a a door that comes in here, and then a ladder, some platforms, able to exit to the next screen over. And in addition to splitting up each of these, the map, into multiple screens, I also want to have a screen be more than a single view width and height. So describe that better. So this is your viewport here. Here's your character. To explore the screen, you can go up, you can go side to side. Sort of the simplest screen might just be a corridor, right? So you can go left, you can go right, enter and exit the screen, and that's it. But you could have a more complicated screen where you have to get up and out to the next screen up here, in which case, there might be platforms that you need to navigate, jump up, or there might be ladders, or let's say there's some vines that you climb up, go over. So in any case, the basic idea is that we'll be procedurally generating these maps that are made up of screens, and you have to be able to navigate the complete map via these screens. So we can do this, using some sort of pathing algorithm like A star. We can make sure that every area that you want the player to be able to reach is reachable by navigating the entrances and exits from the screens. So we'll call that distinct screens. With entrances and exits. Screens are larger than viewport. Uh, and as far as the procedural generation is concerned, I'm not interested in completely randomly generating the screen. I think I'll use more of a Spelunky type method where you have, I don't know how many, you divide each screen into 4 or 8 or more, pieces, and then you have components that you can rotate or flip on the axis. So it's just be a matter of making sure that each of these components, whether it's just a series of platforms or whatever these components are, that when you put them together, that screen, you can navigate that screen and get from one exit to the other. So that we'll have to sort of figure this out. But maybe, if you have an entrance here and you have an exit here, then you have to think, okay, well, you can walk down this corridor and then you can jump on these platforms, climb up this ladder, and then jump out here. So this whole level needs to be, or this whole screen rather, needs to be navigatable. So this is, this would be just one screen of the complete map. And you would have an entrance or an exit here and an exit here. So we'll call those, each screen is made up of composable, call them blocks or components. It should be able to be at least flippable on the x-axis. And again, each screen needs to be navigatable. Is that a word? Navigable from exit to exit. And the Emergent gameplay, talked about that before. You have box 2D, allowing for players to come up with unique solutions. And again, the example which I gave before is, you have a player who needs to get over a wall. They have a bow and arrow. They can shoot the arrows into the wall and use those to jump over. This, of course, is inspired by Deus Ex, where the original one, where players realized that they could do speedruns of Deus Ex by using the mines on the walls in order to get to areas they're not supposed to get to. And finally, again, the two-player system. This is where the name comes from. So there's going to be 2 players. One is going to be your standard adventurer. They're going to use a gamepad or keyboard. And then the player who uses the mouse in the beginning eventually is going to be a tablet or a phone. and actual networking. It's going to control the familiar. Some ideas, the familiar could be, a fairy, sort of like the fairy in The Legend of Zelda. Could be a will-o'-the-wisp. I mean, imp. And the familiar, is going to have some powers, and possibly healing the adventure. Damaging the monsters. We'll call them, sure, let's call them monsters or mobs. Be careful about that, though. You don't want to end up in a situation where the familiar is able to complete a level all by themselves. One of the powers of the familiar is that I think they should be invulnerable to damage. So, if it were too easy for a familiar to just float around the level, killing everything, then that would make the game trivial. And it would also, you need to carefully balance the two roles so that both players are having fun. So just a few more ideas about the game. And I've been looking at the documentation. There's really good documentation about the camera and Box 2D, so I'm beginning to understand a little better. The units in Box 2D are in meters, so that's was part of my confusion, is just that these units don't line up with pixels. They line up with meters, and that's how the simulation works. So I'm going to keep reviewing the documentation, and I'm trying to put another hour or so into this whenever I get a chance. But that's all for me for tonight, and hopefully I'll be able to do this again soon.